In this lecture, we are going to begin discussing Prim's algorithm. In the last lecture, we went over an implementation for Kruskal's algorithm for a minimum spanning tree. And Prim's is very similar to Kruskal's. It's going to help us find a minimum spanning tree. And Prim's is going to start at a single node, and then it's going to move through the several adjacent nodes in order to explore all of the connected edges along the way. And that's the general premise to how Prim's works. So what we can do is we can create ourselves a little graph, and we'll say we have node 0, node 1, 2, 3, and 4. And now we can draw all of our edges, and let's provide them weights. So we have 3, 4, 1, 6, 3, 5, and 2. So what we can do is we can say our minimum spanning tree visited, or vertex, excuse me, parent node, and then the weight. So we know that we're starting out at, we're going to start out at vertex 0. So this will be our start. We don't have a parent and there's no weight, given that this is our starting vertex. So from vertex 0, we will look at all of the neighbors of vertex 0, and we see that we have 1 and 2. 2 has a weight of 4, and 1 has a weight of 3. So for vertex 1, we will say the parent is 0 and the weight is 3. So we can have our visited section over here, and we've currently visited 0 and 1. From 1, our neighbors are 4 and 2, and we see that 2 has a weight of 1. So for vertex 2, we say the parent is 1 and the weight is 1. And then we have vertex 3 and 4. So from vertex 2, and let's add it in here, from vertex 2, we can get to 0, 1, 4, and 3. Well, we already know that we have visited 1 and 0, so we don't have to worry about those. So all we have to worry about now is 4 and 3. And we see 3 has a weight of 5 and 4 has a weight of 3. So the parent to vertex 4 will be 2 and the weight will be 3. And now at 4, we see that we can get to 1, 2, and 3, but we have already visited 1 and 2. So the last vertex for us to go to is 3, so we can just go ahead and assume our parent is 4 and our weight is 2. And now we have a minimum spanning tree that looks something like this. So we go from 0 to 1, down to 2, to 4, and down to 3. And this is what our minimum spanning tree looks like in the solution. So now, in the next lecture, we will begin implementing in Prim's algorithm, and then we will use this graph as our test case to ensure that this is the output that we are able to deduce during our test. So, I'll see you in the next lecture when we begin implementing in Prim's algorithm.